This video tutorial discusses Rhinoceros 3D file preparation techniques for future processing in RHINOCAM 2012. Previous experience is not required. If at any point you would like to follow along, you can access the Rhino 3DM file on the DFAB server or online at www.cmu-dfab.com. The file is titled RHINOfilePREP3. Let's get started. Here we have a file that we would like to prepare for the CNC router. This model is a universal representation of the most commonly used CNC operations within RHINOCAM. Its purpose is left to your imagination. Material selection. When we first begin developing a model for CNC routing within Rhinoceros 3D, it's important that we have a general idea of the size that we would like to work with. Size constraints are limited to material availability and milling bit availability. When we look at this model, we see that our part measures 24 inches by 24 inches by 3 inches thick, indicated by the red dimensions. This would require material that measures 2 foot by 2 foot by 3 inches. Therefore, we have several material choices. When choosing a material to work with, all users should focus on project efficiency. Efficiency is based on cost and time. For instance, we could use 3/4 inch MDF or plywood for successful completion of this model, but that would require the user to glue or laminate 4 sheets of 2 foot by 2 foot stock to achieve the 3-inch required thickness. This takes time, and additionally, lumber materials or materials that are dense usually take longer to mill because of milling bit constraints. Alternatively, we could use 2 foot by 2 foot by 3 inch thick foam for this model. This would be less expensive, and its material properties would allow for faster completion or faster milling time. In this case, foam is a more efficient material for our project. However, the sacrifice we make by using a less expensive and radically different material lies in the post-processing. We would have a difficult time sanding, vacuum forming, painting, and handling foam material because of its material properties. Therefore, if we require heavy post-processing, we should research other material possibilities. For this model, we will assume that we are milling from 2 foot by 2 foot by 3 inch EPS foam, more commonly recognized as styrofoam. A useful tip while developing your model is to create boundaries to build within. For example, I know that I'll be using 2 foot by 2 foot by 3 inch foam, so I will create boundaries that indicate the 2 foot by 2 foot by 3 inch limitations. I use simple but effective squares. You could also create a solid 2 foot by 2 foot by 3 inch box to indicate your build limits, but it can cause difficulties throughout your modeling process when you use anything other than a wireframe viewport. Bit selection. Next, we should focus on bit selection. When creating your model, begin thinking about what milling bits will be used for successful completion of your model. Your selection or choice is dependent on the detail you are looking to achieve and the depth your model requires. Simply put, details are dependent on bit diameter and type, whereas depth is dependent on bit length. For instance, if we look at the top left of our model, we see that we have a small opening that requires a profiling pass. It is highlighted in cyan. The smallest detail is about 1/4 inch. Therefore, I require a 1/4 inch bit, shown here in red. However, I can only use this 1/4 inch bit if it is long enough to cut to the depth I require. If we look at a side view, we can see that my bit selection is not long enough to cut to the depth I require. The tool cone or bit holder will collide with our part. Therefore, I will have to select a bit that is longer. This usually means that I require a larger diameter bit. Highlighted in green, we see a representation of a 1/2 inch diameter bit. This bit will not give us the detail we require, but it will be long enough to cut to the depth we need. If the detail is extremely important, then we must redevelop the model to accommodate for the shorter bit lengths, or find a 1/4 inch bit that is longer. This requires time and research. If at any point you are unsure of bit lengths or bit information, consult the DFAB video tutorial on milling bit information. Additionally, you may consult with DFAB administration. A monitor or a manager can provide you with assistance on bit selection or bit information. Operation preparation. Next, have a general idea of what operations you will be using. Are you drilling? Are you profiling? Do you require 3-axis roughing and finishing operations? It is important that you realize a 3D model is not a sufficiently prepared file. Typically, you must develop 2-dimensional geometry from your 3-dimensional model to successfully complete milling operations. Take a look at the openings on the left side of this model. I require profiling operations to successfully cut out these openings. I know ahead of time that profiling passes require closed planar curves. Therefore, the 3D geometry is unnecessary for anything other than pooling 2-dimensional curves. During this process, you may begin creating your milling geometry and find that there are so many points and lines that it might be useful to organize them onto layers. If you reference this file, you will see that all milling geometry is organized onto separate layers, dependent upon each milling operation I look to complete. Points are organized onto the drilling layer, and profile geometry is organized onto multiple layers. This will be extremely helpful as you move on to creating operations in RHINOcam. If you are unsure what geometry you require for your file, you should consult the DFAB video tutorial on RHINOcam milling geometry. Again, DFAB staff may also provide assistance if necessary. Position. The last step in preparing your Rhino file involves placement. The CNC router's origin point is located at the bottom left of the table. Before beginning in RHINOcam, be sure to relocate your milling geometry to your grid's origin. This means that the bottom left of your model should reference X and Y 0. Also, note that this geometry sits above the C-plane. This will ensure an accident-free job, as the milling bit will not attempt to cut any geometry below Z0. This concludes our session. You are now ready to view the RHINOcam 2012 setup tutorial.